Okay, hello and welcome to class number 11 for defense. I'm taking this class from my mother's clinic today so that there is no issue of construction noises, etc. I hope you can all hear and see me. If that is the case, please write yes in the comments. Please write yes if you can hear and see the slide. Hello and welcome to class number 11 for defense. Sorry about that. Yeah, so if you can hear and see me, please write yes in the comments. Okay, good. Sheetal, Rishabh, Rupam, Priya, Abhinav, Tina, Ujjwal, Shivangi, Anurag, everybody can hear me. So let's get started. Dekho, before we start today, before we start with defense and continue the rest of space, दो तीन चीजें मैं आपको बता देता हूँ. Today we're going to do a 20 question test at the end of the class. Okay, so let's see how you do there. पहली तो एक चीज है. दूसरी चीज, आई वॉन्ट टू टॉक टू यू अ लिटिल बिट अबाउट दिस. ठीक है, कंसिस्टेंसी. नाउ देखो, ऑब्वियसली फर्स्टली आई लाइक टू थैंक ऑल ऑफ यू फॉर द विशेस दैट you've given me. Yes, I was ill. I am still slightly ill. Yesterday I had about 101 fever. Currently it's still there, about 99 to 100. But देखो, बात I'm not blowing my own trumpet here कि देखो मैं कितनी मेहनत कर रहा हूँ और मैंने क्लास करा दी. That's not the point. I could have taken an off and you know that. But the thing is कि इस एग्जाम में you will have bad days. ठीक है, there will be bad days when your mood will be off, when you know something bad will happen, घर पे कुछ खराब हो जाएगा, you'll have to go somewhere, there is some tragedy, you have fever, you're not well, your friend is not speaking to you, etc etc. उन bad days पे आप कैसा perform करते हो, that is what determines your performance here in this exam. Okay, देखो कुछ होते हैं good days. There are some good days where we all feel कि हाँ यार आज तो I'm going to do well, मेरा मन कर रहा है पढ़ाई का. You get up and you feel like that okay, today I'm going to study well, I'm going to do well. Those days are obviously not going to be a problem. The days that are going to be a problem are going to be those where you have issues. इन दिनों पे भी आपको उतना ही परफॉर्म करना है, या उतना नहीं तो एटलीस्ट एक एवरेज परफॉर्मेंस देनी है. इफ यू आर यूजिंग फॉरेस्ट लाइक आई हैव टोल्ड यू, दिस इज द राइट टाइम टू ट्रैक एटलीस्ट 55 hours per week if you are going to give the prelims this year. ठीक है, you have to do 55 hours per week. Now of course I'm not telling you to do 10 hours per day or 8 hours per day, because there will be good and bad days. A good day pe you can study 10 hours, on a bad day you'll probably study 7 or 6 or maybe even 5. But in a week you have to get to 55 hours, because if you do that, if you get to 55 hours in a week, वो ना एक it acts like an addiction, एक नशा सा हो जाता है कि हाँ यार I have to keep performing. And forest use करने को मैं क्यों कहता हूँ, because if you use forest, it will be there in front of you, in like the number will be in front of you. अगर आप खुद से लिखोगे या खुद से चेक करोगे तो पता नहीं चलेगा, बट इफ यू यूज फॉरेस्ट द नंबर विल बी इन फ्रंट ऑफ यू, एंड दैट इज वेरी इंपॉर्टेंट, राइट? सो प्लीज टेक केयर ऑफ दिस. जब अब हम एज वी आर गेटिंग क्लोजर एंड क्लोजर टू द प्रीलिम्स, थिंग्स लाइक दिस बिकम वेरी वेरी इंपॉर्टेंट, राइट? ट्राई एंड रीच दिस नंबर, एंड ये नहीं कि एक बार यू हैव टू रीच दिस, यू हैव टू स्टे विद दिस नंबर. 55 to 56 hours per week you have to do. If you want a break on Sunday, ठीक है, एवरीबडी वॉन्ट्स अ ब्रेक 1 day per week, ठीक है, यू डिजर्व इट, कोई इसमें गलत बात नहीं है. बट इफ यू वॉन्ट अ ब्रेक ऑन संडे, सो यू हैव टू देन स्टडी 9 hours on the other 6 days to get to this number of 54. बिकॉज देखो, यू कैन नॉट कंटिन्यूसली स्टडी. ऐसा तो होगा नहीं कि आप रोज ही 8 घंटे पढ़ लोगे, राइट? देयर विल बी गुड एंड बैड डेज, तो कीप वन ब्रेक डे फॉर यू, राइट? बट on other days, try now reaching this number. And of course your efficiency matters. If number of hours does not matter, but number of hours is the starting condition. If you have the requisite number of hours, if let's say the requisite number of hours is 9 and you have the requisite number of hours, then later the next condition is efficiency. But if you don't have the requisite number of hours, तो आप कितने भी efficient हो, कोई पॉइंट नहीं है. आपको सीट पे तो बैठना ही पड़ेगा 9 से 10 घंटे अब, राइट? So hope you understand that and hope you try and implement it. Now we'll start with space tech, जहाँ हमने कल छोड़ा था with general theory of relativity. Just checking your comments to ensure the video is fine, and then we'll go forward. What is forest? Okay, मैं बताता हूँ. Forest is an app. Forest एक app है that you can use on your phone. On Android it's free, on iOS it's paid. On iOS if you want a free app you can use the app Tide. ये app क्या करता है? It is a tracker. It tracks your daily performance. मान लो आप अपने यहाँ पे forest on कर दो. Right? If you turn forest on तो आपको ऐसा एक ऐप पे you will see a timer. जब वो टाइमर चल रहा होगा उस टाइम पे इफ ऑन योर फोन यू ओपन एनी अदर एप्लीकेशन तो वो टाइमर अपने आप रुक जाएगा. ओके, सो इट इज अ वे टू ट्रैक योर स्टडी टाइम. जब आप पढ़ने बैठो आप फॉरेस्ट पे अपना टाइमर ऑन कर दो. जब आप टाइमर इफ द टाइमर इज ऑन एंड एट दैट टाइम यू गेट डिस्ट्रैक्टेड, मान लो आपने व्हाट्सएप खोला तो आपको एक बार वार्निंग देगा दैट दिस इज योर फोकस टाइम, प्लीज शट द ऐप. अगर आप बंद नहीं करोगे तो टाइमर अपने आप बंद हो जाएगा. So at the end of the day you will be able to see in the timer how much time you have spent doing true focus, where you were not distracted by your phone, where you were not doing anything else. ये है forest. Try and search that. मैंने इस पे एक वीडियो भी बनाई है on my YouTube. It says daily progress tracking. This is the title of that video. You use that. ठीक है, आप वो वीडियो देखना, उसमें पूरा डिटेल में एक्सप्लेन किया है how forest is to be used. But it's just an app that's a timer. ओके, नाउ लेट्स स्टार्ट विद जनरल थ्योरी ऑफ रिलेटिविटी, जो हमने कल छोड़ा था बीच में. वी वर रीडिंग अबाउट ग्रेविटेशनल वेव्स, है ना. ग्रेविटेशनल वेव्स क्या है? हमने देखा था कि स्पेस जो है, स्पेस इटसेल्फ इज अ शीट एंड थिंग्स व्हेन दे हैव मास दे बेंड दैट शीट. ग्रेविटी बेंड्स स्पेस, राइट. एंड अगर दो बहुत ही हैवी चीज़ें, जैसे मान लो जिन्होंने इसको बेंड कर रखा है इस शीट को, दो बहुत हैवी चीजें, दे कम एंड कोलाइड विद ईच अदर और दे स्टार्ट रिवॉल्विंग अराउंड ईच अदर, दे विल क्रिएट रिपल्स इन दिस शीट. जैसे रिपल्स प्रोड्यूस होते हैं व्हेन वी थ्रो वन वन रॉक इन अ पॉन्ड. तो इफ दैट थिंग हैपन्स इन स्पेस दैट इज कॉल्ड अ ग्रेविटेशनल वेव्स, राइट. ग्रेविटेशनल वेव कब होता है? व्हेन कैटाक्लिस्मिक इवेंट्स हैपन. Cataclysmic means events such as colliding black holes, supernova explosion, colliding neutron stars. Now these are gravitational waves. तो gravity क्या करती है? It stretches and squeezes things, bends things. So they are waves that stretch and squeeze things in their path, and they travel at the speed of light because they are waves. Okay, so they travel at the speed of light and they stretch and squeeze anything in their path. Okay, now gravitational waves were detected in LIGO, the Laser Interferometer Gravitational Wave Observatory, right. कैसे डिटेक्ट करता है? पहले हम ये ग्रेविटेशनल वेव का थोड़ा आइडिया देख लेते हैं कि these are two very heavy things that are rotating like this. Now these things, what they are doing, these things, oh so sorry about that, just a second. Yeah, so these things, what they are doing, they are very heavy, and once they come into this sheet they start rotating or they collide. ये ripples, ये वाले जो ripples हैं, ये ripples produce होने लगेंगे. Okay, ये ripples जब produce होने लगेंगे that will be called a gravitational wave. अब इसको टेस्ट कैसे करते हैं ये हम कल पढ़ चुके हैं. This is the Laser Interferometer Gravitational Wave Observatory. इसमें क्या है? दो बहुत बड़े स्केल हैं 4-4 किलोमीटर के, राइट. देयर आर टू वेरी बिग 4 किलोमीटर स्केल्स. जब ग्रेविटेशनल वेव आएगी इट विल स्ट्रेच एंड स्क्वीज एवरीथिंग इन इट्स पाथ. तो ये, बट द थिंग इज इट हैपेंस एट अ वेरी मिनिस्क्यूल लेवल. बहुत दूर से वेव आ रही है तो हमें बहुत सेंसिटिव इंस्ट्रूमेंट चाहिए. तो देयर आर 4 किलोमीटर लॉन्ग 2 scales. They will stretch and squeeze. तो यहाँ पे ये 4 किलोमीटर से मान लो 4.0001 किलोमीटर हो गया स्केल। स्केल में तो चेंज नहीं होना चाहिए, right? But if there is a gravitational wave, this small stretching and squeezing will happen, and this small stretching and squeezing will be tracked. This is what the LIGO does. Now LIGO is doing this on Earth. Problem क्या है कि Earth itself has gravity. तो हम डिटेक्ट तो कर सकते हैं ऑन अर्थ, बट इफ वी डिटेक्टेड ऑन अर्थ तो अर्थ की ग्रेविटी से हमको डिस्ट्रप्शन हो सकती है, थोड़ी डिस्ट्रैक्शन हो सकती है, देयर माइट बी सर्टेन इंटरफेरेंस. सो व्हाट डू वी नीड? We needed something in space to do that. So for that we made the evolved LISA, right? This is the gravitational wave from space. इसने क्या किया? It took 3 satellites that made a 1 million kilometer long equilateral triangle. अब ये क्या हुआ? What is this 1 million kilometer doing? This is acting like that scale, क्योंकि हमने लेजर बीम्स यूज करी. ठीक है, we are using the laser beams. अब इन लेजर बीम्स में these are like scale for us. Now when there will be stretching and squeezing, this 1 million kilometer, this might change. थोड़ा सा ही change होगा, but change होगा. So this interferometer, the LISA, is capable of detecting gravitational waves in space. And since it is in space, it is not interfered with by the Earth's gravity. It is much more sensitive. तो यहाँ यही बात लिखी है. Such a frequency interval is not accessible on Earth because terrestrial gravity noise, meaning that Earth's gravity is doing some interference. So ELISA looks like this. ये हमने कल देखा था. Laser beams like this. Now if there is some stretching and squeezing in space, so there will be tracking on the ELISA. Okay. Next हम देखते हैं gravitational lensing. This is something we did not study yesterday. तो यहाँ तक clear है सबको? This is conceptual, so I'll go slow. All electromagnetic radiation. Okay, how is a wave stretching or squeezing anything? Because it is, gravity is what? Gravity is the bending of space, right? Now when the bending, gravity is what? It is the bending of space. Okay, something like this जो हमने कल देखा है. Now let's say two things that bend space, they have collided. Right, so there will be a wave of gravity because there is a, now exactly how this happens is not even clear to NASA, right? Even they don't know why this gravitational wave is produced. But what you have to understand, or the thought experiment that you can use, is that gravity itself is the bending of space, right? It bends space somewhat like this, like we saw on that trampoline sheet yesterday. So when two things that are bending space, they come together, they collide, or they revolve around each other, they will produce ripples in this trampoline sheet. Now ये जो ripples produce हुए हैं, what is that? First, it is a radiation. All electromagnetic radiation, this is not electromagnetic radiation, but all other electromagnetic radiation traveled at the speed of light. So it was found, देखो, there are two types of scientific findings. One is observed and one is inferred. Observed things means that we just found that it happens like this. Inferred means that from our calculations we were able to infer, or we were able to calculate that gravitational waves would go like this. Currently the findings around gravitational waves are mostly observed findings. We have just observed how these gravitational waves work, right? Because abhi we are still in the process of understanding how they work. So what we have observed in gravitational waves is that it is a wave of gravity. Gravity's job is to bend the space around it. When it bends space, it brings things closer, right? Of course, gravity does bring things close. तभी तो sun की gravity is making earth revolve around it. So a wave of gravity is formed. A wave of gravity would mean that this bending or bringing things closer would mean squeezing. If this is me, I'll just explain on a different page. If this is me and I have huge mass and this is you, gravity would mean that I bend the space around to bring you closer, not attract force. This is what Einstein was saying. This is what we were discussing yesterday. When this is the sun and this is the earth, it is not that the sun is attracting the earth directly, it is just bending the space like this, that is making the earth revolve around it. And ये हमने कल देखा है in that trampoline sheet video, right? So now if a wave of gravity comes that travels at the speed of light, this is an observed phenomena. Now what would that do? It would bend the space around between, like the wave would bend the space. Now bending of space would mean what? If this attraction has to happen, what does it mean? You will have to first squeeze the space, and then once the wave passes, the space will come back to normal. So first there will be squeezing and then there would be stretching. This is how a gravitational wave is squeezing and stretching things. Okay, this is too complex physics for you or needed for you. इतनी बिल्कुल भी जरूरत नहीं है. If you have curiosity, we can discuss this at length, but इसकी बिल्कुल भी जरूरत नहीं है. If you just understand that there is a fabric of space, a trampoline sheet of space, gravity bends that space, and sometimes when huge gravitational objects either collide, either they move around each other, what happens? They create ripples in that fabric of space. That ripples, those ripples are what? Those ripples are nothing but waves. These waves are waves of gravity. So they will squeeze and stretch and they will travel at the speed of light. This is what gravitational waves basically are. Can I move on from here now? Is there any difference between bending of space and bending of space-time? Very good question, Prashant. I will just address that. Gravity is bending of space-time. Gravity is bending of space-time, but I have not explained time yet. This component I am going to explain. Bending of space is the general theory of relativity. Dilation of time is the special theory of relativity, which we are just going to see. Okay, and we don't have to go in this much detail in these things because you are not giving an exam to become an astrophysicist. You just have to understand the basics. Okay, देखो. And this, I hope you've understood now that gravity is bending space, ripples are creating, and anything that has gravity, any object, including you and me, gravity किस में होती है? जिस भी चीज के पास mass है, anything that has mass will have gravity. Even I am bending the space around me, but gravity का जो constant है g, it is 6.67 into 10 raised to power minus 11. It is so small that your mass needs to be of this order. 10 raised to power 11 means mass is in trillion kgs. Around trillion kgs, your mass needs to be there for you to make any substantial impact on gravity. I am bending the space around me, and this bottle right here is also bending the space around it. But the gravitational constant is so small that it makes no appreciable difference. So for it to have an impact, it needs to be a huge mass. Earth bends the space around it. So when Earth is then pulling me towards it, when I jump or when I throw this in the air, it comes back because of the Earth's gravity. Now you can understand this as a force, which is what Newton said, that Earth is pulling. And Einstein said, no, Earth is bending the space around it. So this thing comes back closer. Effect is the same, right? If the Newton and Einstein, they are explaining how they see gravity. They are not explaining how the effects of gravity are different. Effect is the same. Effect is the attraction only, right? Effect attraction ही है, जो sun और earth की attraction है, that is due to gravity. This attraction is explained as a force by Newton and as bending by Einstein. Currently, we have found that Einstein's explanation is better because it explains many other things. But this does not mean that we have conclusively proven anything. और ऐसा ही होता है साइंस में. Experiments keep happening and hypotheses keep getting tested, right? So right now we are seeing that gravity is bending the space around it. अभी सिर्फ space. How gravity dilates time, वो हम अभी देखेंगे. But before that, let us learn this concept called gravitational lensing. I hope this is clear. Now I'll move on to the next concept, gravitational lensing. Good. देखो, now gravitational lensing. लेंस क्या होता है? मेरे ग्लासेस में देयर इज अ लेंस, करेक्ट? थोड़े गंदे हो गए, बट देयर इज अ लेंस, राइट? लेंस इज एनीथिंग दैट इज डिस्टॉर्टिंग लाइट रेज, राइट? लाइट रेज जो आती है हमारी, इफ लाइट नॉर्मली आती रहे, उसको अगर हम थोड़ा सा चेंज कर दें टू मेक इट इजियर फॉर अस टू सी, दैट इज समथिंग कॉल्ड अ लेंस. सबसे कॉमन लेंस हमने क्या देखा है? वी हैव सीन अ मैग्नीफाइंग लेंस. व्हाट डज अ मैग्नीफाइंग लेंस डू? ऐसा करके दिखता है मैग्नीफाइंग लेंस. It looks something like this, right? We put it on a paper and we can see things larger, right? Glasses में भी लेंस होते हैं, मैग्नीफाइंग लेंसेज में भी लेंस है. Now what is lens doing? जो लाइट आनी थी, किसी भी चीज को हम कैसे देखते हैं? This is the sheet of paper, okay? This is my eye. How will I see it normally? Light will come here and then go here, right? ये बात तो अपने को क्लियर है. If I put a lens here, मैग्नीफाइंग लेंस, तो क्या होगा? वो इस लाइट को थोड़ा सा डिस्टॉर्ट करके ऐसा बना देगा, तो मुझे बड़ी चीज दिखेगी. हाउ एग्जैक्टली द रे डायग्राम्स वर्क? स्टेट पीसीएस में पूछते हैं, यूपीएससी में तो दे स्टॉप्ड आस्किंग. सो जस्ट अंडरस्टैंड दैट व्हाट इज हैपनिंग इज इट इज डिस्टॉर्टिंग द विजन. डिस्टॉर्टिंग सीम्स लाइक अ बैड वर्ड, बट वो एक्चुअल से थोड़ा चेंज कर रहा है ताकि हमें बेटर दिख सके. वो मैग्नीफाई कर रहा है, राइट? दिस इज व्हाट अ लेंस डज. लेंस का काम है लाइट रेस को चेंज करना. लाइट रेस को या तो बढ़ा के दिखा देगा या छोटा दिखा देगा. कई लोगों की नेगेटिव पावर होती है, जैसे मेरी है, कईयों की पॉजिटिव पावर होती है. दैट इज बिकॉज लेंस विल डू सम डिस्टॉर्शन. ओके, हाउ दैट वर्क्स वो भी मैं आपको समझाता हूं. ओके, नाउ व्हेन ग्रेविटी डिस्टॉर्ट्स लाइट रेस, अभी तो क्या था कि लेंस वाज डिस्टॉर्टिंग लाइट जो हम यूज करते हैं. अगर ग्रेविटी इस लाइट रे को डिस्टॉर्ट कर दे, राइट, तो what will it lead to? Curving of light, and this will be called gravitational lensing. जो लाइट रेज को डिस्टॉर्ट करने का काम अगर ग्रेविटी कर दे तो इट वुड बी कॉल्ड ग्रेविटेशनल लेंसिंग. नाउ लेट मी एक्सप्लेन टू यू फर्स्ट अ लिटिल बिट. दिस इज नॉट इंपॉर्टेंट, एक बेसिक समझा रहा हूं आपको कि हमारी बॉडी में हमारे पास लेंसेज क्यों हैं. वी हैव एन आई लाइक दिस. बॉडी में एक नेचुरल लेंस होता है यहाँ पे आई में. व्हाट हैपेंस इज रेज कम फ्रॉम हियर and they form on the retina, हमारी eye में, and when they form on the retina we are able to see. This is how the normal body works, body eye works. अब मान लो किसी की eye ऐसी है, again this is not important, I'm just explaining the function of a lens, जिसमें image आगे बन रही है, मतलब it's not reaching till the retina, right? This means your lens has too much power. It is again, देखो यहाँ भी it is distorting the light rays, whatever light is coming, it is changing its path for making it easier to see. तो यहाँ let's say your lens is too powerful, या आपका distort हो गया लेंस, तो आपकी इमेज यहाँ बन रही है, but what you needed was here. So this is called myopia and you would need a negative power lens here, ताकि थोड़ी इसकी पावर कम करके इमेज को यहाँ बनाया जा सके. जो नेगेटिव पावर लोग हैं जैसे मैं हूं, उनके आईज में क्या हो रहा है कि इमेज आगे बन रही है यहाँ पे, जबकि बननी चाहिए रेटिना पे. और कई लोग हैं जिनका लेंस उतना पावरफुल नहीं है, तो उसमें क्या हो रहा है कि इमेज यहाँ बन रही है बहुत पीछे, तो उनको ढंग से नहीं दिखता, तो उनको चाहिए पॉजिटिव पावर. पॉजिटिव पावर मतलब एक और लेंस लगाना है ताकि दी इमेज फॉर्म्स हियर, राइट? सो आपको लेंस का मतलब समझ आ रहा है? इट इज डिस्टॉर्शन. इफ यू हैव अ नॉर्मल आई, योर आई लेंस इज जस्ट मेकिंग द इमेज एट द राइट प्लेस. इफ यू हैव अ बैड आई, राइट, these are both abnormal. First is your lens becomes too powerful. अगर आप ज़्यादा स्क्रीन रीडिंग करते हो, ज़्यादा you study a lot, you will most likely develop this lens power which is positive. तो अगर आपका लेंस, आई का लेंस बहुत पॉजिटिव हो गया, बहुत ज़्यादा आपका आई का लेंस पावरफुल हो गया, तो रेटिना पे इमेज नहीं बनेगी, राइट? बट इफ देन यू विल नीड टू पुट अ नेगेटिव पावर लेंस इन फ्रंट ऑफ इट, कि यार चलो इसकी पावर थोड़ी कम हो जाए. अगर आप your lens becomes too less powerful, then you will need a positive power lens that the image needs to form here. So basically ये बात है कि lens is something that distorts light rays. अब यही काम अगर ग्रेविटी करने लगे, राइट, तो इट विल बी कॉल्ड ग्रेविटेशनल लेंसिंग. देखते हैं ये कैसे काम करता है. देखो, लेट्स से दिस इज अ टेलीस्कोप यहां पे, ठीक है, दिस इज अ सैटेलाइट और अ गैलेक्सी दैट आई वांट टू सी, राइट। नाउ यहां से लाइट रेज आती है, फ्रॉम दिस सैटेलाइट लाइट रेज कम लाइक दिस, बीच में देयर इज एन एंशिएंट गैलेक्सी, another huge galaxy is there in middle, so there is one place, this is where I'm seeing from the telescope. Now ideally अगर मैं टेलीस्कोप से ऐसे देख रहा हूं, if light only traveled in a straight line, तो मुझे ये तो दिखता ही नहीं कभी, I would just see this, right? जैसे this is my hand and I have kept something behind my hand, यहाँ पे there is no appreciable gravity, so you cannot see what is behind my hand because light is traveling in a very straight line. तो लाइट हियर इज ट्रैवल वुड ट्रैवल इन अ स्ट्रेट लाइन एंड बीच में ये आ जाता तो मुझे ये कभी दिखता ही नहीं, ये ऑरेंज कलर। बट लाइट डज नॉट ऑलवेज ट्रैवल इन अ स्ट्रेट लाइन व्हेन देयर इज अ लॉट ऑफ ग्रेविटी प्रेजेंट। अब ये एंशिएंट गैलेक्सी में बहुत ज्यादा ग्रेविटेशनल फोर्स है, राइट, दिस कैन बेंड द स्पेस अराउंड इट, ओके। सो व्हेन लाइट स्टार्ट्स टू कम फ्रॉम दिस dark dwarf or whatever this orange thing you want to call, जो मैं देखना चाहता हूं, it starts coming like this, then it is bent by this ancient galaxy in the middle because of its gravity, and somehow because of that it reaches here. अब ये आपको शायद ये डायग्राम नहीं समझ आएगा because it is a 2-dimensional one, this thing is happening in 3 dimensions, right? But अगर मेरे पास ये लाइट यहाँ पहुंच जाती है due to bending, the ray diagram is not important, the concept is important. There is something in the middle having gravity that can bend light. Because it can bend light, it reaches here, okay? Because it reaches here, I am able to see this. So light rays are getting distorted, making it easier for me to see something जो मैं normally नहीं देख पाता. Normally I would not be able to see this if light was traveling in a straight line, but in this case I would be able to see this, okay? This is gravitational lensing. Now just imagine what I would actually see in the telescope when I'm looked from here. Just imagine and look from here. I would see this blue color galaxy and light traveling around it like a ring, because ये तो 2 ही rays हैं, but there would be a 3-dimensional, right? ऐसे rays आ रही होंगी, so a ring would be visible. This ring is called an Einstein ring. So this is what my image would look like because of gravitational lensing, and this is the actual picture of an Einstein ring captured by the Hubble telescope. This must have been the ancient galaxy that is providing the bending, and ये उसके पीछे की चीज भी I am able to see. So because of gravity I am able to see things which I normally would not be able to see if light was only traveling in a straight line. This is the idea of gravitational lensing, right? You just need to understand the concept. And you need to know this term, Einstein ring. Most likely if the question would be there, they would ask you that the Einstein ring is an application of gravitational lensing. And I think with this diagram things become clear to you, right? Okay. Now, यहाँ तक clear है? Can I move forward? Again, ये conceptual चीज़ है तो slow चलेंगे. आगे we'll do defense, वो उतना conceptual नहीं है. There we'll go fast. Okay, now let's move to the special theory of relativity. देखो, what did Einstein say? Einstein's general theory of relativity was that gravity bends space. What is the special theory of relativity? Special theory of relativity was that speed of light is always the same between 2 points. So between 2 points, between point A and point B, the speed of light always remains same. Now, अब ये कैसे possible है? If one place gravity curves the space and in the other place it doesn't do it. एक जगह है, मान लो ये point A है, ये point B है, एक टाइम पे तो gravity curve कर रही है, सेम डिस्टेंस पे कहीं और gravity है ही नहीं बीच में, तो there is no curving, right? तो फिर कैसे स्पीड सेम रह सकती है? स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम, बट डिस्टेंस तो चेंज हो गया in both these cases, right? If in the first case you go from this point to this point and there is earth, the light beam's distance is different. In the second case, the light beam's distance is the same. So अब अगर दोनों cases में the distance is different but the speed has to be same, so what needs to change? There is only one more variable remaining. In this case, in the first case, when there was gravity between, or some gravitational object between these points, so there will be bending. So distance is here, distance will be more. Here, distance will be less. But it was observed that speed of light is always same. So it was meant that gravity also will have to change time, dilate time for this to work. If the speed of light has to be same, right? If constant speed has to be there, distance has gone up in this first case, then time also has to go up. So time is not a fixed quantity, right? What does this mean? When there is high gravity, right? When there is high gravity, time will also change. Time will also dilate. Time will also increase. This is the relation between time travel and black holes, right? Because black holes have so much gravity that they can even dilate time. Okay. And here we also have to understand कि Earth पे gravity ज़्यादा है, satellites वाली जगह पे gravity कम है. So when we were reading timing services in GPS satellites, this is also another thing that they do, because time is a function of gravity also. Time is also dilated by gravity. Again, this is too complex physics, not important. If you can just understand that speed of light remains same, since the distance changes if gravity is present. यहाँ पर planet है, यहाँ पे कोई planet नहीं है, कोई कुछ नहीं है बीच में, तो distance has changed, speed has to stay same, so time also has to change, right? Now, how detailed and how difficult this is, you can understand from the movie Interstellar, जो मुझे आज तक समझ नहीं आई है. But we don't need to understand that. Okay, we just need to get an idea here. So there are certain conclusions. These are the things you need to remember. Gravity is bending of space-time, right? Bending of space, general theory of relativity. Bending of time, special theory of relativity. Understanding black holes and how we photograph them, event horizon, etc. Special theory of relativity, space-time concept, and gravitational waves in case of cataclysmic events in space, right? These are the conclusions. Directly अगर आपको सिर्फ ये भी याद रह जाता है तो काम चल जाएगा, right? But the basics and the background is important. Okay, now अब इनसे questions कैसे आते हैं, right? वो हम आज देखेंगे. We'll see those questions today. Okay. Now there is something called a tidal disruption event. We just need to understand what this means. इसका क्या मतलब है कि एक black hole है. Like there is a black hole like this. This is a black hole. If a star gets too close to it, if a star is, let's say, revolving in the universe and it gets too close to a black hole, what will happen? The black hole will stretch the star because gravity will pull it in. So star ऐसे stretch होगा and then it will burst. Black hole has so much gravity that if a star comes close to it, it will stretch it and then the star will burst. This is a tidal disruption event. Okay, gravitational forces stretch a star and the star will be ripped apart. All right. Okay. Now there is a binary supermassive black hole system, right? What does this mean? Binary means two black holes. Supermassive, ये हमने देखा था, this is a category of black hole. Black hole system means they are connected in some way. Maybe they are revolving around each other. Was discovered through gravitational lensing of blazar. What does this mean? That blazar is a type of celestial body, right? It is a type of star. What it is not really that important. It is energetic, luminous. It is a type of star. इसकी gravitational lensing के through we were able to see a binary system of black holes, right? Again, how it works is not important, but if the terms are clear to you, the idea is clear to you, you will be able to answer the questions, and I'll show you all the previous year questions they have asked. In the past 10 years, they have asked about 5 to 6 questions from this concept, all of them very basic, right? Much more basic than what we have studied. So आगे के लिए also we are prepared. Okay. अब इसकी significance क्या है? Future detection of gravitational waves में help हो सकती है. This is a binary supermassive black hole. Now, when are gravitational waves created? When a star explodes asymmetrically like a supernova, when two big stars orbit each other, when gravitational objects move at very high speed. इसका relation क्या है? This you don't need to remember or understand. For this I'll have to explain E equals mc squared. Let's just not go there. Or two black holes orbit each other and merge. These are the conditions where a gravitational wave could be created. Okay, all right. Now, next concept we have to understand is the James Webb Space Telescope. हमें पता है where it is going. It has gone to L2, right? अब ये है बिल्कुल normal theoretical चीज. So this we will run through quickly. अगर अभी तक समझ आ गया तो just write yes, so that now I can go through the rest of the things. Yeah, I would really advise you to not go into a lot of detail on this. There is a lot of content on YouTube that will explain it to you, but it's not important. I can spend 1 more hour explaining gravity and bending of space-time, but that's not the best use of our time. So I would really recommend that you not go into that, right? If you've just understood the basics, it's fine. Okay, now we've read James Webb Space Telescope. It goes to point L2. ये हमें पता है. What is L2? We know. It is a collaboration between NASA, European Space Agency and Canadian Space Agency. Basic information. It was formerly called the Next Generation Space Telescope. Now what is the important thing here? It is an infrared observatory. जैसे हमने AstroSat देखा था. AstroSat was observing multi-wavelength 3 things, right? But James Webb Space Telescope only observes infrared. It is only infrared observatory. Okay, so ये एक important point है that you have to remember. What is its goals? देखो, कोई भी ऐसा mission होगा तो उसके क्या ही goals होंगे. If you're sending a telescope into space, what would be its goals? You would want to search for galaxies. You would see how galaxies evolved, how the universe evolved, how the universe works, how black holes work, etc., etc. So these goals, when you get it, unless something बहुत ही outlandish है, so the answer will be all of the above, because it's meant जैसे star formation, first stages of formation of stars, physical and chemical properties of planets, all of these things it's normally going to do, right? It's normally going to do anyway. If you send a telescope in space, this is its normal job, right? एक चीज यहाँ पे है expanding universe hypothesis or Big Bang theory. Now this is again geography, but I'll explain a little bit. Right? Big Bang was the first ever like explosion that happened, right? And that led to the creation of the universe, right? अब इसे expanding universe hypothesis क्यों कहते हैं? When Edwin Hubble, जिसके नाम पे Hubble telescope है, Edwin Hubble ने क्या देखा? He had a telescope, okay, and he was looking at galaxies. He was looking at galaxies. Now galaxies say there was some electromagnetic radiation coming, right? There was some electromagnetic radiation coming from a galaxy. Now what he saw was an idea called redshift. Now what does this mean? He saw that जो galaxy है, all galaxies were constantly moving away from us. How? देखो, and how did he, like, you know, how did he see that? इसने ये टेलीस्कोप में देखा कि देखो, दिस इज अ गैलेक्सी, it is constantly moving away from us. All galaxies are constantly moving away from us. तो अगर मैं टेलीस्कोप पे देखूं तो what would happen if this is the original electromagnetic radiation that I'm observing from the galaxy or I'm observing from a star? It would become like this. Like थोड़े टाइम पहले ये ऐसी थी and then it becomes like this. Over time, this is what was happening because all galaxies were moving away. Right? This is what he observed. Why would this be called a red shift? Because when we were reading the visible spectrum, we read VIBGYOR. R had the minimum energy. Minimum energy means longest wavelength. Longest wavelength and the least frequency. This we know. So it was again observed. This still has not been explained. We have not explained why universe is constantly expanding, but we have observed that things are going really, really far. Okay, all galaxies are just moving away from us, constantly going away from us. And this idea, the radiation that they are emitting are becoming like this. So the original wavelength was this much. Now the new wavelength is this much. The wavelength is increasing. So wavelength is becoming longer. And since red color has the longest wavelength, this phenomena was called red shift. Edwin Hubble, he found this phenomena of red shift, and on the basis of that, it was decided or it was observed that universe is constantly expanding. How it is happening, we don't know. Iske piche there are two things called dark matter and dark energy, which we'll study just after this, right? But expanding universe hypothesis ka matlab ye hai, because when we see things on a satellite, we observe a red shift. Seeing that things are constantly moving away from us, constantly the universe is expanding. How? We don't know yet. Okay. Now moving back to James Webb Space Telescope, this is a collaboration between these three agencies. It is going to L2. It is an infrared observatory. Okay. Now it has goals to observe star formation and planets, etc. This is fairly easy. It is headed for L2 and it is the successor of the Hubble Space Telescope. Earlier we had the Hubble. Hubble was named after Edwin Hubble, who saw this phenomena of redshift. Now, what are the points, what are the reasons for putting it on L2? Of course, one we have already seen, that there is gravity balanced on L2. एक चीज मैं आपको और recommend करूंगा. If you have to understand gravity in your everyday life, just look at it as a force. Unless you are dealing with celestial things, it's better to look at it as a force, because force explains it much easier. If you try to understand the Earth's gravity as bending of space, it will take you at least 4 to 5 hours of research to understand why that happens. You will have to solve something called the Schrodinger equation. Okay, so till you have to understand at your level, just stay with force. देखो बहुत easy है to get dragged into science and to go very detailed into it, but वो पूछ नहीं रहे हैं इतना. हम सिर्फ एक आइडिया ले रहे हैं. जितना वो पूछ रहे हैं हम उससे एक लेवल ऊपर जा रहे हैं बस. राइट? ओके. L2 पे हमें क्या पता था कि एक तो ग्रेविटी बैलेंस हो रही थी. दिस वी सॉ. इट कैन कम्युनिकेट विद द अर्थ एंड विदाउट चांसेस ऑफ एक्लिप्स इट कैन सी अ क्लियर व्यू ऑफ डीप स्पेस. Where was L2? This was the sun, this was earth, this is L2. अब अर्थ सन के बीच में कोई भी रिलेशन हो, आप L2 से बाकी डीप स्पेस आराम से देख सकते हो. राइट? एंड देयर इज द सन बिहाइंड इट. तो सन से क्या मिलेगी? सोलर एनर्जी. So these were the advantages of putting it on L2. Right. Now it has provided astronomers with a glimpse of the early universe. Right. We are able to see the early universe because of James Webb Space Telescope. How? Okay. And what does early universe mean? देखो. Speed equals distance upon time. Speed of light into 1 year means the term light year. This is the distance traveled by light in 1 year. Right? Distance traveled by light in 1 year is 1 light year. ओके, सो लाइट ईयर इज अ यूनिट ऑफ डिस्टेंस, नॉट अ यूनिट ऑफ स्पीड। अब देखो, मान लो यहां से एक लाइट एमिट हुई, लाइट से क्या मिलेगा, मुझे इमेज मिलेगी। अगर मेरी इस बॉटल से कोई लाइट इमिट होके मुझे आईज तक आ रही है, सो आई एम एबल टू सी अ इमेज ऑफ दिस बॉटल। इफ दिस लाइट emission, right, it takes 1 year to reach me, right? So what will I see? I will see the image that was there 1 year earlier, not the image that is there today, because जो image बनी है उसको मेरे तक पहुंचने में 1 साल लगता है। So I will see there will be a time lag of 1 year. So technically I will be looking at the past. I will be looking at what is happening 1 year earlier, right? If the distance is measured, if the distance is so much that even light takes 1 year to travel, when this reaches my eye, only then I'll be able to see it, right? So this is light year. If I am using a satellite to look at the universe जिसका light बहुत ज़्यादा light years में distance है, तो I will be able to see the early universe, not as the universe as it is today. Okay, it has captured an image of this galaxy, again galaxy merger of early universe, and it is visible because of gravitational lensing. You know the terms, your job is done. जेम्स वेब स्पेस टेलीस्कोप की 2 साइड्स है। वन साइड यहाँ पे है सन, यहाँ पे है अर्थ, यहाँ पे L2 पे लोकेटेड है। एक साइड में तो इसे सन से हीट लेनी है, इसे कम्युनिकेट करना है अर्थ के साथ, राइट? दिस इज द हॉट साइड, बिकॉज सॉरी, जस्ट गिव मी अ सेकंड। Just a second. Okay, so on one side it has to take the heat from the sun. Okay, now if it has to take the heat from the sun, this is a hot side. Earth is also here, so this is a communication side also. The other side is a cold side. This is the side where it has to look. It has to look into the other part of the universe. So here is where the mirrors are. The actual telescope is where the actual scientific instruments are. So there are 2 sides. There's the hot side, there's the cold side. Okay, now what are the key features of James Webb Space Telescope? Right, it views the universe in infrared. Okay, so infrared, we have seen it is an infrared observatory. Why infrared? Because of just related with the red shift. इससे ज़्यादा I'm not explaining. This you'll at least have to remember, right? It is the only specialized infrared telescope in space जहाँ पे कुछ भी और, like it's not looking at a multi wavelength thing जैसा एस्ट्रोसैट था. It is only specialized infrared telescope. Now its primary mirror is 6.5 meters. There is a secondary mirror also. What are these mirrors? These are parts of the telescope. It's at L2. It has a sun shield. Sun shield मतलब it has to take energy from the sun, but it cannot get heated up from the sun. So it is a sun. It has a sun shield. किस side पे होगी sun shield? Obviously on the hot side. Now, what are the major instruments on it? There is the integrated science instrument module. There are 3 major payloads. First is the ISIM, then is the optical telescope element, then is the spacecraft element. ये 3 हैं, right? इसमें कौन कौन से instruments हैं? देखो, जहां भी तुम्हें infrared दिखे वो तो इसमें होगा ही, but if you see in the MCQ that there is a instrument here that has the word UV, that has the word X-ray, then you mark it wrong. अगर infrared है तो obviously it's going to be on the JWST. Understood? Okay. Now what will it do? Early universe, exoplanets, outer planets, small worlds, etc. This it will understand. Now, what are the observations that it has made already? First, it has observed Jupiter, right? Now it has seen massive storms, auroras, faint rings, and 2 small moons. These are their names, right? Again, static information, just read from here. Jupiter पे उसने क्या क्या देखा है and what are the things you need to understand? एक तो Jupiter also has rings, but not as not as prominent as Saturn. Then it has moons, and it has the maximum number of moons in our solar system. It is and these are the 4 largest moons. Europa and Ganymede are the most important, right? Again, ये geography है. Great red spot, that is the storm that is happening in Jupiter. This is the great red spot here. बहुत time से the storm is going on. Jupiter is a gas giant, I hope you know, right? So it's made up of hydrogen and helium mostly. And auroras, this happens on Earth also. This is again geography. It's the interaction of magnetic field of sun with our north and south pole. It happens on Earth. So similarly, the magnetic discharge or the solar flares interacting with Jupiter's magnetic field would lead to auroras there. Again, ये geography है, तो please जब आप space tech पढ़ रहे हैं तो geography से space वाले chapters revise कर लो, right? Okay. Now, what other thing it has seen except for Jupiter? It has seen pillars of creation. Now, pillars of creation are places where new stars are forming within dense clouds of gas and dust. This we have already seen, right? That we understood कि nebula के अंदर stars बनते हैं. So they are three-dimensional pillars, right? And they at some times they emit semi-transparent near infrared light, and this is why this infrared observatory can see these pillars of creation, places where stars are being formed, new stars are being formed. These are pillars of creation. ये भी उसने देखा है. This is one of the images, the actual image from the James Webb Space Telescope, something that we were never able to see before. ये है क्या? We'll just see. अभी मैं आपको आगे बताऊंगा ये actually हो क्या रहा है. But this is basically star formation happening in a nebula, something called a cosmic cliff. We'll just see what it is. Okay. So this is what one of the images that it has shown to us. All right. Now, other thing it has observed is exomoons, and Indian Institute of Astrophysics में they have developed a model to trace habitable exomoons. Habitable means places where we can possibly live, with the help of the JWST. How do you get and how do you see them? इसका एक model बनाया है. Now, what are exomoons? They are natural satellites that revolve around exoplanets. What are exoplanets? Planets outside the solar system. So outside the solar system जो planets हैं, उनके जो moons हैं, where we can possibly live, those can be looked at using James Webb Space Telescope. और उसका एक model बनाया है at the Indian Institute of Astrophysics. Right? 5,000 exoplanets have been discovered, and natural satellites remain untraced. Right? तो exoplanet तो हमने बहुत discover कर लिए, but the natural satellites are untraced. So that is why we have formed this model. Okay. Now, these are the other observations that James Webb Space Telescope has done. Right? Now, अब यहाँ पे again I will do a recommendation to you. Just know these terms. Right? Just we have to understand these terms. SMACS 0723. It is a cluster of galaxies. WASP 96b. It is a planet outside our solar system. Southern Ring Nebula. It is a planetary nebula. Stephan's Quintet. This is a set of galaxies. Carina Nebula and Cosmic Cliffs. This is what we have seen in that picture. This was the name of the nebula. And these were the cosmic cliffs, places where stars were forming. And it has seen Einstein ring. This also we have understood what an Einstein ring is, right? So you need to remember these terms, what they basically are, and just that they are observed with JWST, not in detail also, right? Okay. There are some other terms like Kuiper belt. Again, geography hai. Just read from here. I'm not going to explain what Kuiper belt, asteroid belt, exoplanet and nebula is. यहाँ लिखा है, you can read it, but this is basically geography, and I expect कि इतना आपको आता है, especially if you are giving prelims this year. If not, when you read geography, it will be fairly clear. Okay. Now this is a comparison between Hubble, Webb, and the Herschel Space Observatory. This Herschel is also planned for the L2, right? So this is again a small comparison table. As you can see, James Webb Space Telescope looks at newborn galaxies. So 13.5 billion years ago. Hubble's main job is to look at young galaxies 12.5 billion years ago. So why 12.5 billion years ago? It will look at places whose distance is 12.5 billion light years. So you're looking at it today, but since light has taken 12.5 billion years to travel, you are seeing something 12.5 billion years back. Okay. This is an important thing. Is Hubble serviceable? Yes. because it's in the low Earth orbit. Is Webb serviceable? If there is a problem in JWST, can we go there? No, because it's 1.5 million kilometers away in the L2 point, right? But again, अब दूर देखना है तो you'll have to place the thing far. But again, then the problem is if it develops a problem, you cannot go and service it. What are the wavelengths? Here you can see again infrared and submillimeter, only infrared, and यहाँ पे visible, UV and near infrared. So Hubble is multi-wavelength, but Webb and Herschel are mainly focused on infrared. Okay. Now let's go to the Parker Space Probe. Parker Space Probe is NASA's mission, a mission that has flown through the sun's upper atmosphere. It is a space mission that has actually touched the sun, right? And it is part of NASA's Living with the Star program. All right. Named after this person, it has a carbon shield to protect from sun's heat. Now, it is the first spacecraft in history to touch the sun. The important thing that you will forget or mark wrong, it uses a series of gravitational encounters with the planet Venus to go to the sun, not the planet Mercury. जब हम सोच रहे होंगे in the prelims, if it says that Parker Space Probe used a series of gravitational encounters with Mercury to touch the sun, it would seem correct कि Mercury sun के पास है तो Mercury की gravity को use करके it must have touched the sun. But the idea here is, this is a statement, this is a fact that it has used the gravity of Venus, right? So these things you remember and you highlight specifically. All right. Okay. These are the layers of the sun. Yeah, again geography hai, but I've written how I used to remember it. I did not have a very good mnemonic. If you have it, you can mention it in the discussion ताकि सबकी help हो जाए. This is how I remembered it. Korakov, chrome and corona. Korakov, I could remember Korakov because the sounds that you hear when you take a patient's blood pressure, those sounds are called Korakov sounds. Okay. So that is, I mean, that's how I could remember it, but you can use a different mnemonic. These are the layers. There's a core, there's a radiative zone, convection zone, photosphere, chromosphere, and corona at the top. These are the 6 layers. This they can ask you. Now, again, अब देखो अगर ऐसा कुछ आ जाए कि what is the relevance of Parker Space Probe, इसका फायदा क्या है? तो भाई सन की evolution, extreme weather events, solar storms, solar flares and solar storms, ये हम अभी पढ़ेंगे, right? What happens in solar storm, etc. These things it will do because इसका काम है sun को study करना, right? What is India's mission to study the sun? That is called Aditya L1 mission. Okay, that is India's mission to study the sun, right? Okay, so let's take a break for 5 minutes. Here we'll continue with the relevance of the Parker, we'll continue with solar flares, right? What solar flares are, how they impact. After solar flares, we're going to do a little bit about Artemis 1. This is important this year, right? Some other terms in space. And then I think here we are starting with defense. So hardly 10-15 slides of space are left. So let's just do space. जो रह गया 10-15 minutes और लगेंगे. Let's take a 5-minute break, and from here we'll continue with space. All right, so we'll start with solar flares after 5 minutes. I'm putting a timer. Cool. See you in 5 minutes. Oh. Okay. Uh, right. Hope everybody can see and hear me and everything is like visible. Welcome back. Yeah, yeah, the black screen was there too because we were taking a break for 5 minutes. Can you see and hear me now? Yeah, okay. Yes, Abhishek, there was a black screen because we were taking a break. I needed to take some medicine. All right, so let's continue back. All right, so let's continue with solar flares. So, what are they? They are sudden explosion of energy, okay, caused by reorganizing of magnetic field lines near sunspots. Basically, क्या होता है? There is some change happening in the magnetic field of the sun. Sun has a magnetic cycle, right? In the magnetic cycle, inside the sun, there is a dynamo mechanism. So let's say this is the sun. It has in its inside two magnetic particles like this. Okay. In the deep interior of the sun, because of its magnetic cycle or the changes in the sun's magnetic field, these two things that develop like spots develop. They are dark spots developing inside the sun due to the magnetic field of sun. This is called a solar dynamo mechanism. These dark spots are also called sunspots. Okay, dark spots are also called sunspots. Now, they appear dark. Why are they appearing dark? They appear dark because they are cooler than the other parts of the sun. Right? Their sunspots are cooler than the other parts of the sun. Right? Now, inside the sun, due to some magnetic field changes, these dark spots develop. Then, after some time, they come to the surface of the sun. When they come to the surface of the sun, right, they can cause the release of plasma and hot gases from the sun. This release is called a solar flare. This, see, the magnetic field of the sun has led to the creation of these dark spots. Where are they created? They are created in the interior. When they come to the surface, they lead to release of certain plasma and hot gases. Okay, when they lead to this release of plasma and hot gases, this is called a solar flare. What actually is being released is a high energy X-ray radiation, right? High energy X-ray radiation and highly accelerated charged particles are leaving the sun's surface because of these solar spots or sunspots. So hot plasma, high energy X-ray radiation, charged particles, they are being released from the sun's surface. Now, what is the outermost layer of the sun? It is a corona, right? So it is called the coronal mass ejection because many things en masse are being released from the sun's surface. So it is called a coronal mass ejection. Happening why? Happening due to the sun's magnetic field. Because of the sun's magnetic field, this is happening, right? This is a solar flare happening due to the sun's magnetic field. Highly accelerated charged particles are leaving. Hot plasma, coronal mass ejection. This much is clear? Okay. Now, energy, radiation and high energy particles emitted by solar flares, right? So there is release of energy, there is X-ray radiation, there is high energy particles, there is plasma that is released due to the formation of these sunspots from the sun, right? Now, Earth itself has a magnetic field. All of this was happening because of sun's magnetic field. Some changes in the sun's magnetic field, solar flare was happening. Earth also has a magnetic field. Earth's magnetic field, if I was to observe, right? If let's say this is the North Pole and this is the South. Okay, I'll just draw it normally only. Let's say this is the North Pole and this is the South Pole. Earth's magnetic field looks something like this. These lines depict the magnetic field of the Earth. So at the North Pole, the magnetic field lines are closest to the surface. Same at the South Pole, right? At the North and South Pole, the magnetic field lines are closest to the surface. Why this is there, you don't need to know, or if you need to know, you have to read in geography. But at the place of the North Pole, the magnetic field lines are closest to the Earth's surface. Again, same at the South Pole. So when certain magnetic field elements are released from the sun, they interact with the magnetic field of the Earth. They interact with the magnetic field of the Earth. This interaction leads to the formation of auroras. What is aurora? You must have seen those images of northern lights, right? Those beautiful lights that are occurring in the sky at the North and the South Pole. Those are the auroras, right? When solar wind or solar flares or particles from the sun that are emitted due to the magnetic field of the sun interact with the Earth's magnetic field, they will interact everywhere. But where will we be able to see them? We will be able to see them where the magnetic field is closest to the surface. That is true for the North Pole. That is true for the South Pole. So there we see aurora lights, right? Aurora or northern lights or southern lights, same. Now, auroras in the northern hemisphere are called aurora borealis and aurora borealis or northern lights, and in the southern hemisphere, aurora australis or southern lights. If you have to remember this, what you will have to remember, Australia is on the southern pole, close to the southern pole. So you remember from here, right? Aurora australis, southern hemisphere, southern lights. Aurora borealis, this is boreal forest. If you read geography, you will realize that boreal forests are in the northern plains, northern part of the world. Or aurora polaris, these are the northern lights. So because the Earth's magnetic field interacts with the magnetic radiation or solar wind or solar flare released by the sun, but this interaction happens maximum, or we are able to see it maximum at the place where the magnetic field is closest to the surface. It leads to the formation of lights, which I'm sure you must have seen. If you haven't, just Google northern lights and you'll see what it looks like. These are called auroras. At the North Pole, it will be called aurora borealis. At here it will be called aurora polaris. Okay. All right. Now, what are the possible effects of this solar flare on Earth? देखो, these are release of magnetic particles, magnetically charged particles from the sun, right? So these can have an effect on what things? जो भी हमारी communication systems हैं, right, where we are using electromagnetic radiation, electromagnetic spectrum we have understood, जहां हम ये spectrum use कर रहे हैं वहां पर ये interfere कर सकता है, because as we have seen, any star like the sun emits the entire spectrum of EM waves, right? पूरा spectrum of EM waves is emitted by something like the sun. Okay, so it can interact with the entire spectrum. तो जहां भी हम ये EM wave अपनी लाइफ में यूज कर रहे हैं वहां there could be a possible problem, right? So what is the problem? There could be an effect on space missions, there could be an effect on radio transmissions, right? There could be damages to astronauts in outside spacecrafts, there could be damages to satellite communication systems, power distribution stations and electronic equipment. Wherever we are using this electromagnetic wave, there might be a problem. Now, this is the classification. B has the least intensity, so least effect, and X has the maximum intensity, so maximum effect. Classification is not that important, but the effect, what it can affect and what it can't affect, and the concept that it is happening due to magnetic field of sun and there is interaction with magnetic field of earth, because obviously magnets will interact, right? This is important. Now, what is a solar cycle? This is the change in the magnetic field of the sun. So every 11 years sun's magnetic field completely flips. Okay, that is, the sun's global, like sun's magnetic north will become the sun's magnetic south, and the sun's magnetic south will become the sun's magnetic north. Every 11 years this is happening. Now, this change can be tracked by sunspots. Why can it be tracked? Because sunspots are generated because of the magnetic field. If there is a change in the direction of magnetic field, there will be a change in the direction of sunspots. If there is a change in the direction of sunspots, we will be able to track whether there has been a change or not, right? If the new solar cycle starts, that means again there is a change. Like, let's say this was the north and south and the new cycle has started, so it becomes like this. At this time the number of sunspots will go back to minimum because the magnetic field has now reset. Now again sunspots will start producing, so this time is called a solar minimum. Okay, then again when it starts to form, then the sunspots will grow. So by tracking sunspots, I can also track a solar cycle that changes every 11 years. Okay, is this much clear? Okay. All right. Now, I hope like this idea is clear that because of sun's magnetic field, sunspots are generated. Those sunspots lead to the creation of solar flares. They are magnetically charged particles that interact with the Earth's magnetic field. If space is not becoming clear to you, you should probably spend some time reading space from geography, because I cannot teach you the basics of space as well as space technology. The basics of space are taught in geography, the first 3-4 chapters. So if you have a good idea of that, this will become easier, right? Okay. Now, next thing we have to study is NASA's Artemis 1 mission. Artemis 1 mission is meant to build a long-term human presence at the moon, right? What is it? It is so it is basically, you want to build on moon a long-term human presence. Okay, so you want to establish people there for a long term. So what are we doing right now? NASA right now is taking an uncrewed flight test. That means without crew, they are sending a test flight to the moon, right? and then once that is established, then they will start sending crew also. Okay, they are planning to land the first woman on the moon with this Artemis mission, right? Okay, so Artemis 1 has three main components. It is the space launch system. Just one second. Okay, so it is the space launch system rocket, SLS rocket, space launch system. It is the most powerful rocket in the world that can take you to deep space, right? Deep space is beyond the solar system or beyond the Earth's, like moon and Earth. And if you go into interplanetary exploration, that would be deep space. So it's possible of taking you to deep space. This is the first thing they want to test. They are basically testing that will we be able to take people across the globe to different planets, etc. For that, they have the Artemis mission. First, they are taking it to the space launch system rocket, or a rocket that will take them to deep space. The second thing is the spacecraft. The spacecraft is what will carry the astronauts, right? It is the only spacecraft that is capable of crewed deep space flight, right? So they are testing these three things: space launch system rocket, Orion spacecraft, and ground systems at the Kennedy Space Center. So ground at the Kennedy Space Center they're testing, the Orion spacecraft they're testing, and the space launch system they're testing. These three things they are testing with this Artemis 1, so that future, if we have to do deep space exploration, it can be done. All right. Now, what are the objectives? First, Orion is the thing that carries the the astronauts. Its heat shield has to be tested, that when it is in high heat conditions, when it's leaving the atmosphere, when it's entering the atmosphere, it can, you know, tolerate that heat. Okay, then radiation environment of deep space. All right, then once it comes back to Earth, it will obviously be made to splash down in the ocean. So wahan se can we retrieve it, right? Then flight test objectives and study the moon, because they're trying to go to the moon. So these are the objectives of the Artemis 1 mission. One other objective is to put the first woman on the moon. All right. Okay. These are some of the other lunar missions by other countries that you just have to see. It's a table here. I'm not reading this. You can read from the slides. Now, okay. So now when the Orion spacecraft, this is the spacecraft that will carry the astronauts. Currently, we have sent an uncrewed one to test it. If everything goes well, then we'll send the crew. So once it goes closer to the moon, it uses something called a retrograde orbit, right? So here what you need to know is that when Orion goes to the moon, it will use a retrograde orbit, and this retrograde orbit will help it come back to Earth when it needs to. Okay, so it will stay in this orbit, and come back to Earth, it will get some gravity assist from this retrograde orbit. Now, what is a retrograde orbit and what is a prograde orbit? If the Earth, like this is the direction in which Earth is revolving around the sun. Okay, if the Earth's rotation is in the same direction, the direction of the Earth's rotation is in line with the revolution direction, it will be called a prograde orbit. Earth is going like this around the sun in this direction. If Earth also rotates in this direction, it will be called a prograde orbit. If something is going around the sun like this, but it rotates in this direction, it will be called a retrograde orbit, right? Just the meaning of the term is enough. If it is rotating like this, opposite to its direction of revolution, it will be called a retrograde orbit. If it is rotating like this, similar to its direction of revolution, it will be called a prograde orbit. All right. Next, we have to see space sustainability. अब देखो, let's do word breakdown. What does sustainability mean? ये मुझे बताओ यार comments में. What does it, if I say sustainable development? Okay. What do you understand? What does the word sustainability mean? Just understand, उससे हमें खुद ही समझ आ जाएगा space sustainability क्या है. Because if आई कैन नॉट टीच एवरीथिंग, बट अगर क्वेश्चन आए तो आपको सॉल्व करने आने चाहिए. सो व्हाट इज सस्टेनेबिलिटी? टेल मी दैट. देखो, sustainable development, okay, what would that mean? It is development that takes care of the present generation, आज की जो जनरेशन है उसका नीड पूरा हो, and the needs of the future generation. I don't think I'll be able to teach defense today. I'm getting a lot of cough. I have a lot of pain in my neck also. I might end the class early, right? Okay, so sustainable development is if there is needs of the present generation and needs of the future generation, they are both met, right? This is called sustainable development. So what would be space sustainability? Space sustainability would be sustainability in space. For sustainability of earth would mean that we are using space in such a manner that today's needs are also met, and future generations, when they need to use space, they would also meet, their needs would also be met. If we launch too many satellites today and then we don't retrieve them back, we create a lot of space debris, then for future generations it will lead to a lot of problems. So right now what we are doing is sustainability. That means what we're trying to do, that today's needs are met but future generation needs are also met. When you are doing sustainable development, there are two concepts. मेंस के लिए बता रहा हूँ. There are two concepts. There is intergenerational equity and there is intragenerational equity. Meaning that intergenerational means current generation, today's generation and future generation, they have, their needs are equally important, right? So you cannot just pollute today and forget about the next generation. Intragenerational equity means that within this generation everybody is equally important. This was asked in Means 2020. How are the ideas of intergenerational and intragenerational equity connected with sustainable development? So if you know the meaning of the words, it's very easy to write, right? Intergenerational equity means today's generation, future generation, same. Intragenerational means that everybody is equally important. All right. Okay. So now what are we doing for space sustainability? There is a United Nations Office on Outer Space Affairs. Okay. They have with the collaboration of Government of Austria organized the World Space Forum. This is a platform to discuss space sustainability so that all humanity can continue to use outer space for peaceful purposes. Okay, what are the threats to space sustainability? Of course, one threat will be space debris and crowding of the orbit. Second threat would be militarization and weaponization of space. Like if you use anti-satellite weapons, when we see defense, we will see this. India also has anti-satellite weapon. Russia has anti-satellite weapon. These are the four countries. This is a weapon used to kill the satellite of other country, right? Let's say China launches a spy satellite over India and we go for a war. Now they are able to see our troop movements. So we will need a weapon to destroy that satellite. But what will happen when we destroy that satellite? So many pieces will form in the orbit and so much space debris will collect. Okay. Then there is rendezvous and proximity operations, meaning you are altering space objects to bring them close to each other. This is also done in case you want to destroy or interfere with somebody else's satellites. And then there is space weather. One idea of space weather is solar flare. Okay. One idea of space weather is solar flare. So these are the things that are threat to space sustainability, that might lead to space sustainability not being established, right? What are the initiatives for that? There is that we have taken globally. There is the UN Office on Outer Space Affairs. There is a conference on disarmament. There are guidelines on space sustainability by this stands for United Nations Committee on Peaceful Use of Outer Space. United Nations Committee on Peaceful Use of Outer Space. This is the It should be like this. PUOS. So just correct this, please. United Nations Committee on Peaceful Use of Outer Space. Okay. There is a space sustainability rating, and there is a anti-satellite test ban resolution. That means you will not test for anti-satellite weapons. This was passed by the UNGA, but it was a non-binding resolution, since resolutions that are passed in the General Assembly of the United Nations are not binding on member countries. Only resolutions passed in the Security Council are binding on member countries. Okay, so it said you ban the testing of anti-satellite weapons. If you have to use it in war, you'll use it, but stop the testing. Okay, this is the initiatives towards space sustainability. What are Indian initiatives? We have already seen space situational awareness. Then we are doing space weather monitoring, right? Near Earth objects monitoring. Project Netra we have seen. Then there is Digantra. Digantra is a space sector startup, and it is going to make India's first commercial space situational awareness observatory. There is a India-USA bilateral space situational awareness agreement. What is space situational awareness? We have read at the time of space debris. And there is a SPADEX. This is an in-orbit servicing platform by ISRO. Means that in orbit you can service the satellite when needed, so you don't have, its life will increase, so space debris will go down. Okay, all right. Now the Committee on the Peaceful Use of Outer Space, it sees 5 agreements. They are written here, and I just expect you to read them. It's fairly easy. What the Outer Space Treaty is, what the Rescue Agreement is, Liability Convention is, Registration Convention is, and Moon Agreement is. Right? This is a committee of the United Nations. So this is where we're done. Okay, no, still some things are left in space. Right. One thing is Goldilocks zone. Ab dekho, again, this was asked in the prelims once, and people did not know what it is. But if you know the story of Goldilocks, right? What is the story of Goldilocks? That she wanted her porridge to be just not too hot, not too cold. So just perfect, right? So Goldilocks zone is that zone where the conditions are just perfect for a planet to have life, because water has to remain in liquid state. That temperature has to be there. If it's too cold, water will become ice. If it's too hot, water will become vapor. So that exact thing, right? Our Earth, for example, is in the sun's Goldilocks zone, exact zone where there will be no there is the exact condition for formation of life. So recently this planet was discovered in the Goldilocks zone of some other star. Which star? Not important. Okay, just the term is important. Then there is Greased Lightning 10. Greased Lightning 10 is a plane by NASA, right? It has 10 engines, and what is the special thing? It can take off like a helicopter but fly like an aircraft, right? It can take off like a helicopter, fly like an aircraft. This is the special thing that they are testing. So this is Greased Lightning 10. Again, it's a PYQ, just need to know. Us time news mein tha, abhi news mein nahi hai. All right. Now, this is important. There is a IceCube Neutrino Observatory, right? IceCube Neutrino Observatory. It is an array of 5160 optical sensors buried inside a cubic kilometer of ice beneath the South Pole. Okay, beneath the South Pole, beneath 1 cubic kilometer of ice, this has been buried, right? All right. Why is it there for? It is there for understanding what neutrinos are and to detect dark matter. All right, now what is dark matter and dark energy, that we'll just see. But this is there to understand what neutrinos are and what dark matter is, right? When neutrinos interact, right, they give an idea of where dark matter is located, right? So to understand what dark matter is, we have created this IceCube Neutrino Observatory. Neutrino derives from the word neutron. Neutron and proton, we have already read, are there in the nucleus. So neutron's smaller element is the neutrino. What exactly neutrino is, we'll read when we read nuclear technology, nuclear fission and nuclear fusion. All right. Okay. So this is the start of defense. Just give me a second. All right. So we're just starting with defense now, but I'm really unable to go on for today. So let's just stop here, right? We'll start with defense tomorrow, and by tomorrow or maximum by Thursday, I'll be back in the studio, so it'll be better. Let's keep today's class a little bit short. We've done most of it. The last thing, that space that we've left, is dark matter and dark energy. Okay. Let me just explain that to you in brief. Okay, and then we'll do that in detail in the next class and then continue with defense. Okay, so there are two things: dark matter, just giving an explanation, just giving you an idea, not going into its detail. Dark energy, right? What did we read? We read the red shift. Red shift was happening because the universe is constantly expanding. Okay, but for anything to constantly expand, constantly grow, go away from us, some energy is needed. You need certain energy. This energy, so far we have not understood. We don't know what is causing this universe to expand. Okay, we have no idea. All right, so we have called it dark energy. We know what dark energy is not. हमें पता है कि ये नहीं हो सकता, ये नहीं हो सकता, it's not gravity, it's not this force, it's not that force, this we know. But what it actually is, we have no idea. It is what is causing the universe to expand. This is all we know, and this is called dark energy. Out of the entire universe, if I would say the entire universe is 100 units, matter that we can see and interact with, you, me, planets, sun, etc., this is just 5%. 70% of the universe is composed of dark energy, and we don't know what dark energy actually is. The other 25%, the remaining 25%, is dark matter. Now please don't confuse, dark matter is not black hole. Okay, black hole is what? Black hole is concentration of gravity at this one very small point, singularity. That is black hole. Dark matter is scattered matter in the universe. Okay, what is dark matter? I'll just explain. पहले dark energy समझते हैं. Universe is constantly expanding. This was seen through redshift because the wavelength was looking like this. It started looking like this. So we saw okay, there is a red shift happening. Now this red shift could only be explained through a mysterious force called dark energy that makes up 70% of the universe. 5% is visible matter, or matter that we are always interacting with, that is around us. That is 5% normal matter. Now what is dark matter? Right, so when we saw galaxies are what? Galaxies are collections of stars and planets. Okay, collections of stars and planets. Now these stars and planets, they were together. Like we have the Milky Way galaxy. The sun is a star in the Milky Way galaxy. So they have all come together, and they are interacting with each other. They are joined together. Now if we are to look at their gravitational force, if all these stars have come together, right, if all these stars have come together in something like a galaxy like this, gravity must have attracted them to keep them together. Like sun's gravity is attracting the earth, gravity must have attracted them to keep them together. But when we mathematically studied the galaxies, we found that the gravity that is there of all the stars, this gravity is not enough. This gravity is not enough. It's the gravity generated, the bending generated, the force generated is not enough to keep all these stars together mathematically. So there must be some more gravity present. Where is this more gravity coming from? This more gravity is coming from certain particles that do not absorb or emit light. They do not absorb light, they do not emit light, but they have mass. if something does not absorb or emit light, it does not absorb light, it does not emit light, it will appear completely dark. If something has mass, it is called matter. So this is dark matter. It's not a black hole. Black hole is concentrated like this. Dark matter are scattered particles. They are providing the missing mass, missing gravity in the galaxy. Because when we account for dark matter, then we can say that gravity is enough to hold the stars together. So this is dark matter and dark energy. We'll see that in detail tomorrow. I'm just stopping today. Okay, tomorrow we'll do this and we'll finish defense. All right. However, my job for today is done, but your job isn't. So now I will expect you to do 15 questions on space. I had also planned some more questions on defense, but since I'm unable to teach anymore, so we'll just do that tomorrow. So this is the cutoff that I had thought of, but since there are going to be only 16 questions, so the cutoff for you now is, let's say, 14. Okay, 14 is the cutoff, and there is a test of 16 questions now for you. Rest we'll continue tomorrow. Let's keep today's class short. Let me just recover and then we can continue normally from tomorrow. Okay, so space में one problem you're facing is that there's too many facts. है ना? देखो there are, right? Space में there's nothing you can do, and if you, but इसमें दो चीज़ें करते हैं. एक चीज़ क्या करते हैं, let's do the questions, तो आपको एक आइडिया हो जाएगा कि कैसे questions पूछे जाते हैं स्पेस में, right? दूसरा क्या करेंगे, one pager, I've already made one for space. I'll add more things to it. I'll update it and I'll revise it with you tomorrow. Defense भी, space भी. तो आपको एक और वो मिल जाएगा, उसमें जो जो लिखा होगा ना बस वो याद कर लेना, राइट? आई थिंक दैट इज फेयर. जो उसमें होगा बस वो याद कर लेना, बाकी छोड़ देना, राइट? देखो स्पेस है टफ यार आपको. आई एम गेटिंग अ लॉट ऑफ कमेंट्स सेइंग बायोटेक वाज इजी टू लर्न. ऑफ कोर्स बायोटेक इज इजी टू लर्न, राइट? बिकॉज स्पेस में एक तो इवन वी डोंट नो ऑल द थिंग्स येट, राइट? बट द पॉइंट इज इफ देयर विल बी 10 क्वेश्चंस फ्रॉम साइंस एंड टेक, स्पेस विल हैव 1 क्वेश्चन, बायोटेक विल हैव 5, राइट? एंड ये चीज आप किसी भी पुराने प्रीवियस ईयर क्वेश्चन में प्रीवियस ईयर पेपर में उठा के देख लो, क्योंकि स्पेस इज दैट टफ. एंड अंडरस्टैंडिंग स्पेस इज नॉट दैट इंपॉर्टेंट फॉर अ सिविल सर्वेंट इफ यू हैव अ बेसिक आइडिया. यू जस्ट नीड अ बेसिक आइडिया, राइट? बेसिक आइडिया कहाँ है एंड कहाँ खत्म होता है ये हम 1 पेजर में कल डिसाइड करते हैं. आई विल रिवाइज द 1 पेजर इन फ्रंट ऑफ यू. उसमें अगर आपको कंसेप्ट याद है तो काम चल जाएगा. ओके, आई होप दैट्स फेयर, राइट? इज दैट ओके विद एवरीवन? ओके, नाउ स्टार्ट. ये तो हम कल कर चुके हैं, बट स्टिल यू सॉल्व दिस. ये अगर किसी ने अब गलत किया फिर देखना. आई एम गिविंग यू जस्ट 30 सेकेंड्स फॉर दिस. प्लीज डिस्कशन में सारे आंसर्स लिखेंगे. Okay, done. Second question. KJ, just write the answer, not the explanation. I know I have not taught you this. You still have to attempt it. You can get this question wrong. It's totally fine. Okay, done. Next. बढ़िया, सबने वही गलती करी है जो मैं एक्सपेक्ट कर रहा था. गुड. ओके. ओके, नेक्स्ट. ये भी हमने कल किया था, तो प्लीज ये गलत मत करना. सबने गलत किया. थर्ड. शाबाश. ओके, डन. नेक्स्ट. Good. Subhashri, good. Good job. Okay, we're done. Good. Anshika, Mitoz, Mahi, Vaibhav, good. Do this. Okay, done. Do this. Sujata, Piyush, Shivangi, Sangeeta, Mohammed, Antaksh, Ekta, Jayashri, good. Amit, Shreya, Simran, good job. Okay, next. Okay, done. This now do this. Thank you all for participating very actively. Rashmi, explanation mat likho yaar. Let others also solve. Good that you know. Good. Shrishti, PC, Kritika, Bruce, Alyash, Anjali, Sangeeta, Mahima, Abhishek, Surbhi, Ashif. Good. Okay, next. Hmm. Good. Priya, Ahom, Shreya, Soumya, Shady, Shady R. Okay. Trina, Kritika, Ditya, Amit. Good. Polmi, Disha. Good. Ajinkya. Good. Sayam, Sangeeta. Good. Shivani, Shubham. Good. Okay. Next. This question, it's very important for you to get this right. Good. Palyash, Ritvik, Ashita. Good. Ash, Himanshi, Vibha. Good. It's important for you to get this one right. Harsh, KJ, Manuraj. Good. All right. Do this. Just a hint for those of you marking it wrong. Okay. This one. Okay. Good, yaar. Yes, Ashif. Good. Good. Thank you all for participating actively. Okay. Do this. Just one more question after this. Okay. Last question. Good, yaar. See, this means you have understood. Good job. Okay, done. Now these are 4 defense questions, but this we'll do tomorrow. Now, सबसे पहले, before we discuss anything and we discuss the answers, firstly, people who are participating actively, you are increasing your chances of clearing the exam by at least 50%. Because देखो, आप खुद से नहीं करोगे MCQs, और खुद से आप PYQs तो डेफिनेटली नहीं करोगे, चाहे आप टेस्ट सीरीज कर लो. दिस इज वाई आई एम ट्राइंग कि यहाँ पर हो जाए, right? This is why I'm trying to you do it in front of me. Secondly, these are all the questions they have asked on space in the past 10 years. How many questions were there? 16. So only 1 or 2 questions. And as you would have seen, most of them are fact based, right? Not a lot of conceptual understanding was required except for the questions on gravity, except for the questions on PSLV, GSLV, right? That is why I have taught you gravity in detail, PSLV, GSLV in detail, but not the other things in that much detail, because वो पूछते ही नहीं है, and it's not the best use of our time this close to the prelims. If we were doing this course in December 2022, it would be a different story. Even then I would recommend कि आप ये चीज़ें ना करो, but as you would have seen now, they don't ask you that much detail because it's genuinely difficult to understand. You need a very good understanding of physics to understand space. People who are from a non-science background will have a lot of problem in this. Biotech mein, if you see, they have asked about 30-35 questions, more than that, in the past 10 years. But here they have asked only 16. So we have to give appropriate time. Similarly for defense. Defense में क्या है कि हमें पढ़ने में बहुत मजा आता है defense, right? But how many questions have been asked in 10 years? 4. So you give time appropriately. So in science and tech, time needs to be given to biotech, which we have done. Time needs to be given to nanotech, which we have done. Time needs to be given to emerging technology. This we will do, right? These are the things, and time needs to be given to nuclear technology, because these are conceptual things. Space you will have to mug up to some level, because there are names of projects, there are names of spacecrafts, there are what they are doing, etc. The conceptual part we have broadly understood, but understanding the human body is easy because you can relate to it. Understanding space and physics will obviously be more difficult, right? And it also puts a constraint on me as to which level I can go to explain. All right, now let's do the answers. This one I'm not explaining because I explained yesterday. Gravitational constant is very small, so gravity यहाँ पे not correct लिखा है. Gravity cannot be the strongest force, right? Gravity actually is the weakest natural force. Okay, all right. Second, this I'll explain. Dekho, this was asked in 2014. I have not taught you this. I don't care if you got it right or wrong, right? I am just showing you the sort of question they ask. So for this, what we're going to do, we're going to give you a table of all the important missions that are there, that are in the news this year. I'll upload that by today or by tomorrow. Just need to read that and keep those things. इस तरह की जो चीजें होती है ना, facts, these you keep for your last minute revision. ऐसी चीजें आप मार्क करके रखो कि यार ये चीजें मुझे भूलेंगी, so I need to keep that for the last minute, right? Answer here is 2 and 3 because Cassini-Huygens is for Saturn, but this is not what they're going to ask you now. ये तो हो गया ना. this we have read, this option you should have gotten correct, but इससे आपको आंसर नहीं मिलता. Okay, just showing you the sort of questions. They will not repeat this exact question because that year these missions were in the news. Today they are not in the news, right? All right, यहाँ पे explanation है. Cassini-Huygens is actually for Saturn. The other two are correctly matched. All right, then ice cube. Ice cube is a particle detector located at the South Pole. This question I was expecting that all of you will do wrong, and that's exactly what you did, right? सबने ये क्वेश्चन गलत किया है तरीके से, and it was on the lines of my expectation. So first thing is fine, third thing is fine, right? सबने C ही मार्क किया है. Now let's look at this. The idea of telescope, ठीक है, telescope का मतलब is not only looking through lens. Telescope can also be an observatory. आपको ये लग रहा होगा कि समथिंग इज बरीड डीप इन आइस, तो फिर वो टेलीस्कोप कैसे हो सकता है, राइट? यही डाउट आया होगा कि अगर आपने डीप बरी कर दिया इसके अंदर, देन हाउ इज इट अ टेलीस्कोप? अगर हमें बाहर की इलेक्ट्रोमैग्नेटिक रेडिएशन देखनी है टू चेक इफ समथिंग इज हैपनिंग, इलेक्ट्रोमैग्नेटिक रेडिएशन इज नॉट लिमिटेड बाय ऑब्जेक्ट्स इन इट्स बिटवीन इफ इट हैज हाई एनर्जी. क्या कह रहा हूं मैं? अगर मान लो मुझे एक्सरे डिटेक्ट करने हैं, इफ आई हैव टू डिटेक्ट एक्सरेज, एक्सरेज हम क्या करते हैं, हम बॉडी के थ्रू एक्सरे लेते हैं, तो वो फिल्म पे एक ब्लैक कलर का ऐसे एक्सरे आ जाता है, राइट? सो एक्सरेज कैन पास थ्रू माई बॉडी, राइट? तो इफ देर इज एन इलेक्ट्रोमैग्नेटिक रेडिएशन दैट हैज इनफ एनर्जी, it will be able to pass through stuff, right? It will be able to pass through stuff. जैसे X-ray can pass through my body, light cannot pass through because light में उतनी energy नहीं है, visible light, but X-ray can pass, cosmic rays can pass. अब खुद सोचो, अगर हमने किसी चीज को डार्क मैटर डिटेक्ट करने के लिए रखा है, डार्क मैटर अर्थ पे तो है नहीं, डार्क मैटर कहाँ है? डार्क मैटर है स्पेस में, फिर भी वी हैव बरीड इट डीप इन द आइस, राइट? आइस के अंदर हमने बरी किया है, फिर भी वी आर डिटेक्टिंग डार्क मैटर फ्रॉम स्पेस. सो व्हाट मस्ट बी हैपनिंग? सम रेडिएशंस मस्ट बी कमिंग दैट आर एबल टू क्रॉस दिस आइस एंड स्टिल रीच द आइस क्यूब, राइट? And if it is an observatory that looks at things in space, it can be called a telescope. Okay, traditionally telescope must have a mirror. But if it is an observatory, that is basically ये क्या कर रहा है? It is looking into space. That is what a telescope does. So it can be called a telescope, right? सिर्फ समझाने के लिए था ये क्वेश्चन. I could have put the word telescope in the slide also, तो आसान हो जाता. If you have marked this wrong, it's absolutely okay. But understand the concept now. Okay? Right. Yes, Ashif. Okay. This is it. Now, this is very simple. This we have read, so I'm not explaining. It can take off like a helicopter, fly like a spacecraft. Now, astrosat. What did I tell you? When there is data, be very skeptical about data. This statement is wrong, and this is also wrong because Japan also has one and many other countries have one. So first and second both are wrong. Now, this basic factual question, again just to understand कि वो questions कैसे पूछते हैं. They did not ask मंगलयान कौन से उससे गया, what is the difference between an orbiter, a lander and a rover, what is it finding, what are its payloads. जो scientific चीज़ें हैं वो नहीं पूछ रहे, वो ब्यूरोक्रेटिक चीज़ें ही पूछ रहे हैं कि इंडिया फर्स्ट है क्या, इंडिया फर्स्ट टाइम में पहुंच गया क्या, थिंग्स लाइक दैट. एक बेसिक अंडरस्टैंडिंग लेके these are the things we're supposed to be dealing with. Answer here is 1 and 3 because other countries have also done this before us, and this we have studied when we were reading it, right? All right, and we were the fourth people to go, not the first, not the second. All right, Okay. Now this we have already seen, ELISA detecting gravitational waves. ये वो conceptual पूछते हैं. तो अब देखो कितने questions हैं gravity पे. ELISA they asked gravitational waves in 2017, right? In 2017 they asked singularity, event horizon connected with gravity and black hole, right? जब इनको प्यार हो जाता है किसी टॉपिक से, they'll keep asking it. Done? Okay. Then they, okay, let's look at this. Now again, IRNSS, this is navigation with Indian constellation, India's regional navigation system, correct? Sorry, I went quickly through this. I hope this is clear. Event horizon, singularity, this is understanding of the universe, because we have already read these things in universe, right? So this is fairly clear. Okay, अब बस याद रखना that in 2017 they asked about gravity and black holes twice. Okay, now let's see what's going to happen आगे. In 2018 they asked about IRNSS. Again, data. Wherever there is data like this, you can understand that it will be wrong, because it's 1500 kilometer. Now you don't need to read option 3. So if in the prelims, actual prelims में आपको ऐसा हो कि time कम पड़ रहा है, you are in a fix and you are able to eliminate this, यहाँ आपने देख लिया one only या none, मत पढ़ना 3. It's only there to confuse you. Just don't read it if your time is less. Otherwise you can read it. India will have its own satellite navigation system with full global coverage by the middle of 2019. Of course not. So this is also wrong. This statement is correct and we have read also, right? Okay. Now 2017 gravity asked twice, right? Into 2 times they asked gravity in 2017. In 2018 light is affected by gravity, universe is constantly expanding, matter warps its surrounding space-time. Okay, again 2018 gravity got repeated. Answer is D. All right, let's see आगे. 2018, next question. In which of the following areas can GPS technology be used? Why are we using GPS technology? For positioning, for timing. GPS is obviously used in phones. You can use it for banking also, timing and positioning, and you can use it for power grids also, timing and positioning. So answer is D. Wide thinking in science and tech. Okay, you know the idea of GPS, you know what trilateralization is. Wide thinking, fairly easy answer. Good God. All right. Now, with reference to India's satellite launch vehicles, consider the following statements. Now, PSLVs launch satellites useful for Earth resources monitoring. Polar satellite launch vehicle launching polar satellites for Earth resource monitoring. And GSLVs mainly to launch communication satellites, geosynchronous and geostationary. Satellite launched by PSLV appear permanently fixed in the same position. Of course not. This is true for geostationary, not for polar satellites. So second statement is wrong. Actually, they have if the word here was GSLV, then it would be correct, right? So second statement is wrong. Third, GSLV Mark III is a 4-stage launch vehicle. No, PSLV is a 4-stage launch vehicle. Which is the stages? Solid, liquid, solid, liquid. Okay, answer here is 1 only. All right. Now, 2017 gravity into 2, 2018 gravity, then 2019. Scientists observed the merger of giant black holes. Merger. If they were wanting to detect singularity, they did not need a merger of black holes. You could have just seen black holes directly through the Event Horizon Telescope. But merger of black holes, collision of black holes, cataclysmic events in space-time lead to what? Gravitational waves. Okay. All right. So we have seen 2017, 2018, 2019. Gravity 1, 2, 1, 1. All right. Okay. Then 2020. ELISA was asked. Okay, this they had asked before. Same thing they had asked before. Same thing they asked again. Right? 1 million kilometers long equilateral triangle. Why is it there? For gravitational waves. So again in 2020, gravity and gravitational waves repeated. Okay, all right. We have read this. Now, 2021. Again, general and special theory of relativity. Right? General and special theory of relativity is gravity bending space-time. General theory explains that gravity can bend space-time, and how time comes into it is explained by special theory of relativity. ये आपको समझ नहीं आया शायद कई लोगों को, तो I'll just explain this at the end of all the questions. Astronomical distance measured in light years. Again same thing. Light years में क्यों distance measure कर रहे हैं? Distance, speed is equal to distance upon time. Speed into time is equal to distance. Speed of light is always the same. This we have already seen. And speed से ही relation होगा distance का. This is one way to solve it. Other way you can see the options. Distance among stellar bodies do not change. Of course, you know this is wrong because the universe is expanding. Gravity of stellar bodies do not change. This also you know, and this has nothing to do with distance anyway, right? Light always travels in straight line. This is also wrong. And speed of light is always the same. This is the thing that's correct. अब ये देखो, they have made it extreme here to give you a doubt, but when concepts are clear, you will not have a doubt. So again, gravity was repeated in 2021 also. Then this is the last question. Solar flare happens on Earth. Now, solar flare was due to magnetic movements on sun. So whatever electromagnetic communication we are doing, that can be affected by solar flares. GPS could be affected, yes. Tsunami needs an earthquake to happen. This is basic geography. Tsunami needs an earthquake to happen. Second is wrong. Just eliminate second and you're done. Don't even read the rest. But you'll still read. Power grids, yes. Auroras, yes. Forest fire. Solar flare is a magnetic phenomena, not a heat-based phenomena. So the answer 5 you eliminate. Even if you could just eliminate 5, you would get the answer, which is C. Orbits of satellites, yes, because satellites are magnetic components. Short wave radio communication, yes, especially over polar regions, yes, because polar regions will have maximum interaction. Okay, now one question with regards to, are we done? Yeah, we're done. Okay, now one question with regards to what you were asking, how gravity changes time. Gravity bends space-time. This is the assumption of general theory of relativity. To explain the space component, we saw gravitational waves. To explain the time component, there is the special theory of relativity. What is the special theory? Special theory says speed of light speed is always same. ठीक है, all right. Regardless of what are the circumstances, speed of light is always same. First case is, this is point A, this is point B. Light travels in straight line. There is nothing in between these two things. Okay, distance between A and B, or let's say displacement between A and B, is the same. It will always be the same, right? Light is traveling in a straight line, so speed is equal to distance upon time. Now, regardless of the circumstances, what happens between A and B, the speed has to be the same. Now, what happens? Suddenly a star comes here. It was revolving and a star comes here. Now, because of the star, what will happen? There will be bending of the space. So light, how will light travel? Light will now travel like this because of the presence of the star. Okay. Light will now travel like this. But the distance between AB, light can travel any way it wants. Okay, light can choose to travel any way it wants. But the distance between A and B has not changed. Distance between A and B has not changed. Only the way light is traveling has changed. Right? Now, distance that light has traveled has increased. Distance that light has traveled is increased, but this equation S is equal to d by t cannot change. Distance, actual distance is same. So in the second equation, in the second case, S second, speed in the second case, will be the new distance, I'll say nd, upon the time. But the the second case speed has to be same as the s1, the first case speed, right? Again, I'm going in such depth because there were questions. This much depth is not required. Okay. First case speed was distance between A and B divided by time. Second case distance S2 will be the new distance traveled. The new distance traveled by the light, distance between A dash and B dash divided by time of the second case. Okay. Now we have learned that S1 and S2 have to be the same because speed of light is always same. So distance between AB traveled in the first time divided by time 1 is same as distance between A dash and B dash and time 2. Now it's pretty clear that A dash and B dash, this distance is longer. So I can say, since this has to be equal, but this figure is bigger. So if distance between A and B, if DAB is 1, and this is T1, and this is 2, and this is T2, right? If I say distance A dash B dash is twice of that here, so I will get T2. In the second case, the time taken is 2 times into T1. So because of gravity, time has been dilated, increased. Because speed of light is constant, it has changed the distance light has to take, so it has changed the time light takes, right? And this time is dilated because of gravity. That's all you need to know. Changed due to gravity. All right. So that is it for today. You can take a leave. If you have any general questions that you want to ask, I'll just stay here for 5 minutes and talk to you. All right, just let me drink some water and we can do that. You can take a leave, and tomorrow we'll continue with defense. Finish defense, just one class because only 4 questions have been asked in 10 years. And then we'll move on to emerging technologies. Thank you. Yes, Karthik. No, Preeti, it does have 7. Okay, you can ask any general questions that you have now. Thank you for your wishes. Thank you. Just give me a minute. Marks are not relevant in this test. I gave you the marks to give you any pressure. It's fine if you got all the questions wrong also. Shubham, general theory of relativity predicts that gravity bends space-time. To explain the time component, there is the special theory. But general theory also makes that prediction. Bilkul Sandy. No an issue. Thank you. रेहान क्लास तो ली नहीं जा रही यार, यूट्यूब पे क्या वीडियो बनाऊंगा मैं, दे दो थोड़ा सा टाइम, आई विल मेक इट. No, you don't need a big chart paper. I'll tell you what you need when we get there. Shalu, really? That is amazing. Why do you want to go there, Taruna? Why do you want to go there? That I know that is the one line to explain the general theory of relativity. You must have seen it in that video. But why? Why do we have to go there, यार? क्यों जाना है इतना डिटेल में? सॉलिड यार, बोथ फर्स्ट स्टेज इज सॉलिड. वो बूस्टेड नहीं है, इट इज द स्टेज, वो डिजाइन बस ऐसा है. फर्स्ट स्टेज इज सॉलिड. यार दिस टाइम might be difficult for me to do economics. Yes, yeah, it will not go beyond 20th for environment and science and tech. This I can promise. एक दो दिन it will go late for science and tech because of my health. Sorry about that. Use Forest on the iPad. No, I'll do it, Tejal. Interesting question. अरे आने तो दो रिजल्ट यार. यार इकोनॉमिक्स very difficult for me to do for 2023. Can do for 24. Yes, it. Why does that matter? By the way, Gayatri. And no, it doesn't change. Speed of light changes. Side of sound changes with medium, not speed of light. IR I'll announce soon. Ash IR बता दूंगा यार. Just let me recover a little bit. पक्का बता दूंगा. Just give me some time. Thank you, Uttam. Kriti, most of them. Kirti, sorry, most of them. अरे आरुषि क्या क्या करवाओगे यार. Thank you, Kaushal. 76 as a score in a sectional test. देखो, it is slightly low, but it depends which test it was and which coaching it was. Sometimes the tests are made deliberately tough just to lower your confidence. Gravitational encounter means you are using the gravity of some planet to increase your speed or to continue with your mission. थोड़ी सी आपको bending मिल जाए with the help of the planet's gravity. Second, yes, not first. Ravinsh. करते हैं कल. कूल तनु. यार जो IR के PT365 में है वो. अर्पित, I have not done it. Yes, Mia, they are visible. अरे आयशा यार टेंशन मत बढ़ाओ. मई में ही आएगा. 24-25 मई को आपके प्रीलिम से 2-3 दिन पहले. यू पोस्ट ऑन माई टेलीग्राम ग्रुप. कार्तिक, बहुत लोग यूज करते हैं वहाँ फॉरेस्ट. पूर्वा देखो, 110 plus in previous year questions out of 200 is a less score. I'll tell you why. Previous year questions ना cover हो जाएंगे आपके when you read books. तो वहाँ आपका score 130-140 होना चाहिए because you would have covered them in some way or the other. Yes, Ashif, I'll teach them. And only the Nobel prizes in science, not all of them. जैसे mitochondrial DNA के लिए Nobel prize has been given to Svante Pabo, so I'll teach you that when we do role of scientists. Economic survey and budget. बनाते हैं यार इस पे वीडियो. Just give me some time. हर्षित, यूज इट एज अ गुड प्रैक्टिस. हरियाणा PCS का अगर प्रीलिम्स है ना, मैंने भी उसका फॉर्म सिर्फ इसलिए भरा था ताकि मेरी प्रैक्टिस हो जाए. तो यू विल गेट अ वेरी गुड प्रैक्टिस फॉर द एक्चुअल प्रीलिम्स. अरे कहाँ मैनेज हो रहा है जयश्री. मैनेज हो जाता फिर तो क्या बात ही थी. कहाँ टाइम मैनेज हो रहा है मेरे से. आई नो हर्षित, इट्स ऑन 21st May, राइट? सो व्हाट यू कैन डू इज यूज दैट एज प्रैक्टिस एंड फोकस ऑन दिस. दोनों पे फोकस मत करना. देखो, दोनों में डिफिकल्ट होगा. यार आशिफ, आई विल कवर द नोबेल्स फॉर श्योर. वन पेज है फॉर पॉलिटी. यार मेरे पास थोड़ा तो टाइम मुझे भी दे दो यार. लेट मी हैव सम रेस्ट आल्सो. 50-60% is good, Amit. Yes, Vaishnavi, I will. Tanu, you'll have to pick one. Prelims clear तो करो, किशन, then I'll do it. PYQ से ही पता चलता है यार. स्वरूपा, मैपिंग कर लेना उसके अलावा एंड डू GC लियोन. क्या कर रहे हैं अतीश माथुर सर, शांतनु? जो भी कर रहे हैं बढ़िया ही कर रहे होंगे यार. ही इज अ वेरी नाइस पर्सन. स्वप्निल, 1 पेजर फॉर इकोनॉमी. यार इकोनॉमी में लेकर आना बहुत मुश्किल है यार इस साल. आई विल नॉट कमिट समथिंग दैट आई कांट डू. 20th के बाद मैं क्या करूंगा, विल सी. मे बी आई विल फोकस मोर ऑन लाइव सेशंस एंड गाइडेंस फॉर दिस थिंग, ताकि आपके डाउट्स क्लियर हो जाएं. पढ़ो तो थोड़ा खुद से, जितना मैं इस 2024 के लिए पक्का. आदित्य इज नॉट इम्पॉर्टेंट. हाँ हाँ अभिषेक, 100+ तो बहुत है. तरुण क्यों दिक्कत ले रहे हो भाई, मैं करा रहा हूँ ना एनवायरमेंट. आशिफ यार मैं ठीक हो जाऊँ फिर पक्का. ऐस जाओ खा लो. गो हैव लंच. Piyush, I'm not actually. I wanted a break regardless of the result. तो बढ़िया है फिर, अगर अतीश माथुर सर कर रहे हैं तो कर लो वहां से. ही इज वेरी गुड फॉर पॉलिटी. यार पॉलिटी इकोनॉमिक्स तो अभी तक हो जाना चाहता है हिमांशु. हाँ हाँ लोमेश, करेंगे बिल्कुल करेंगे. यस अमन, इट्स गुड आइडिया. अमित क्या प्रॉब्लम हो गई? Nimwards, I lot of mistakes and lot of introspection. Ashita, you tell me how to fight, if you understand how you can fight fatigue. If you're talking about fatigue with like health, that is a different thing. But yes, fatigue for the exam, that's a normal, that does happen. So I'll recommend that you take a break for 1 day. But see, it's not about taking a break by just not studying. What you need is a mental break. Even when you're not studying, a lot of times what is going through your head is the exam. You're always thinking कि मेरा वो subject रहता है, या this is what I have to do. So when you're able to fight that feeling, that's very important, right? So what you need is a mental break that can be done even while studying. So I would recommend going out with some non-UPSC friends for some time, where you would just forget the exam. That would help you go for maybe fight that fatigue. Other than that, you can try switching subjects. Sometimes we get very bored, but देखो 60 days are left, right? Less than 60 days are left. I'm not going to tell you that you can take it easy. You can't. Okay. यार जो IR के PT 365 में होगा वो, चारू, नथिंग मोर नथिंग लेस. मैंने नहीं दिया आज तक विजन अभ्यास यार, तो मैं नहीं बता सकता. फोरम के सिमुलेटर, अलाउद्दीन खिलजी. एंशियंट मेडिवल पे वीडियो बना रखी है अमित. आई हैव ऑलरेडी मेड. आशिफ विल टॉक ओवर ईमेल. ओके, सो दैट्स इट आई थिंक फॉर टुडे. कोई नहीं, बाकी कल बात करते हैं. थैंक यू फॉर योर टाइम, थैंक यू फॉर लिसनिंग, and we'll continue tomorrow. Tomorrow we'll first, I'll do the space 1 pager with you, I'll give you that table of those space missions that you have to remember from this year's current affairs. We'll do defense, and we'll do defense questions also. So tomorrow we'll be done with space and defense. Tomorrow is Wednesday, right? Just so disoriented. Right, okay, tomorrow is Wednesday. So after that, it will take 2 classes for us to finish emerging technologies. Now, once emerging technologies is also done, most of the science and tech is over, right? So on 31st, we'll be done with most of the things. But because we had to like take a couple of gaps, I will probably need 1 or 2 more classes to cover very small things like energy. Now, the thing with energy is that energy is also important for environment, right? So I'll make it in such a way, whenever I cover it, I'll make it in such a way कि दोनों चीज़ें cover हो जाएं. And same thing for IPR and role of scientists. जो IPR and role of scientists वाला issue है, वो है बहुत छोटी चीज़, उसमें कुछ बहुत ज़्यादा नहीं होता. We will only cover what IPR is, what Nobel Prizes have been given recently, what Indian scientists have done. Energy we can probably do with environment, or we'll figure something out there. Okay, so most likely by Saturday, or at the most by Monday, we'll be done with science and tech. If we go to Monday, then energy will also be covered, so a huge part of environment will also be covered, right? So I'll plan it in that way, and then till 20th we'll be done with both science and tech and environment. All right, thank you for watching. See you.